Hello everyone, I hope you are doing well and welcome to this time of class. We will learn about vectors in this class, okay? So in physics what we do is we measure different things. For example, you can measure your mass, you can measure your height, you can measure your distance, you can measure speed, you can measure force, you can measure time and a lot of things, right? So we measure quantities, okay? So let's just say we measure measurements, okay? So for example, what are the measurements? You can measure time, you can measure speed, you can measure force, and you can measure maybe distance and a lot of other things, right? So why do we measure them? Because we want to calculate something that we don't know, or we want to predict something for our use, okay? So you can have other quantities as well that you can measure. But our main topic is about vectors, okay? So there are two types of quantities that we can measure, okay? One type is a scalar, the other type is vector. Okay, so what are scalars and what are vectors? Scalars are very simple. These are the quantities that can be represented, that can be completely represented by just a single number. We call that number a magnitude. Okay, what does that mean? I will explain that in a minute. So scalars are the quantities only require number to represent, and we also call that number magnitude. Okay, so they only require a number to be completely explained. For example, time. If I ask you that how much time it takes for you to go from your home to your school, you might say an hour, you might say half an hour, you might say 10 minutes, you might say 15 minutes. So you're just giving me a number, and that number can completely it can completely give me all the information that I need to know. Okay, for example, the time, right? Time. Another example we can take is of, for example, if I ask you what's your weight. In physics we call it mass. Okay, so what's your mass? You may say it's 100 pounds, 140 pounds. So see, you are only giving me um, the number, right? 140, 150. The pound is actually the unit, that's something else. So 140, and I have a complete information about your mass. So that means that is also a scalar, your mass. Okay, but for example, let's take an example. I have a box, and I say that I am applying a force on this box. And as a physicist, you should be able to calculate where this box moves. Okay, even if it moves. So you should be able to tell me where this box moves. Okay, so let's say I say that I'm applying. You might have heard of word horsepower. People use that in vehicles, right? So let's say you're applying a force of 5 Newton. In physics, we use Newton. Okay, 5 Newton of force. That's a unit of force. You don't need to worry about that right now. So I'm applying a 5 Newton of force on this box. Where this box moves, you don't know. It's impossible to tell where this box will move if I just tell you that I'm applying a 5 Newton of force on this box. But what I need to specify is the direction, in which direction I am applying the force. Am I applying the force in this direction? Am I applying the force on this direction? Am I applying force on this direction? So wherever I am applying a force, the box will move there. So that means to completely specify, to completely give you the information of a force, you not only need a number, you also need a direction, right? Only then you will be able to calculate something, only then you will be able to predict something. Predict, for example, where this box will move. That's something that you can predict. For example, if two people are pushing in this direction, okay, and one person is pushing in this direction, then what we say, where this box will move, of course, towards these two people, because they can apply more force. So that's why the direction is actually very important when we are um, telling something about force. So force is a vector. Okay. So for example, force. So that's it for this demo class, and I hope you understand it. Have a good day.